All right, welcome back. So in this video, we're just going to talk first about writing a periodic function in some special way. So let me explain what I mean there. So let's say you have, let's let f of t be periodic. With period t. Okay, so one of the ways the book likes to write it is they like to say we have f of t equals f sub t from 0 less than t less than t, and then periodic. That's the information they like to give you. So I want to talk about how we could write that out formally, okay? So our f of t, well, would definitely be equal to this thing, right? I should write a t there. For its first period. So that's going to be from 0 to t of t. So that's the window function from 0 to t of t. Then next, it's going to be equal to f sub t of t minus capital T. This is for the second period. Okay, plus, that should be the second period. So that should be from t to 2t. Okay, plus f sub t of t minus 2t. This should be on the third period. Okay, so what I want you guys to sort of think about is when I write this out, this is what's sort of going on here. Okay, so we have here, let's say here's t, here's 2t, here's 3t, keep going to 4t. Okay, so there's some definition of this function. Okay, now I'm going to take that, of course, copy it. Oh, I don't want that bit. Oh, I should probably make these open circles here. Okay, let me copy that again. Okay, so what's going on is that the ft is only defined, the f sub t is only defined from here to here. But then here, if I go here, I'm just going to subtract off the t, and it'll bring me back here. Here, it'll subtract off 2t, so it'll bring me back here. I can do this again. If I'm here, I'm going to subtract off 3t. Okay, so that's going to bring me back 1, 2, 3t to here. Okay, so that's where this sort of notation is coming from. Okay, so let me see this question in the book because I'm looking. So we're going to do number 6 in the section. Actually, no. We're going to do, yes, number 3 in the section first, which says, sorry about this. Sorry, number 2 in the section. That's the one I wanted. Okay, find the Laplace transform okay, where f of t equals e to the t from 0 to 1, and f of t has period 1. Okay. Okay, so this part's actually this one's easy. All right. Not easy, but easier than finding the inverse, which we'll see on that. Okay. So L of f equals ft of s divided by 1 minus e to the ts, negative ts, sorry. Okay, what is our f sub t of s? Well, in this case, t equals 1. Okay, and this is the integral from 0 to 1 now of e to the t, e to the negative st dt. Okay, so that's going to give us 0 to 1 e to the negative s minus 1t dt. Okay, just written down somewhere just so that I okay, just want to make sure that I don't screw it up because I'm prone to doing that, as you guys know. That equals e to the negative s minus 1t divided by negative s minus 1 from 0 to 1. Okay, let's go ahead and plug in 0 and 1. So when I plug in 1, this is going to give me 1, right? Because you're going to have e to the 0. And when I plug in 0, it's going to be e to the t. So I'm going to get, sorry, when I plug in, what am I thinking? These are t's equals 0 and 1. See, this is why I have this down. So when I plug in t equals 1, I'm going to get e to the negative s minus 1. And when I plug in t equals 0, I'm going to get 1. So this is going to equal, or this equals 1 over s minus 1 times 1 minus e to the negative s minus 1. Okay, so this pulled out. I changed the negative sign. At 0, this is going to be 1. And at 1, this is going to be negative s minus 1. And the reason that this one came first is because I got rid of that negative sign. Okay? So now, the Laplace transform of our total f is going to be 1 over 1 minus e to the negative s times s minus 1 in the denominator with 1, let me write it 1 minus e to the negative s minus 1. Okay. All right, I'll see you all in the next video.